Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
We will talk about the design of internal combustion engines with multipoint injection, because this is how the abbreviation MPI, multipoint injection, sounds in translation. Before the emergence of gasoline power units with direct injection, FSI, TSFI, GDI, it was the MPI engine installed on the entire range of Volkswagen, Seat, Skoda, Mitsubishi, Renault, Ford, and cars of many other manufacturers. Let's consider the device, principle of operation and design features of the multipoint injection system on the valves. Design. Schematic representation of the Mitsubishi Motors multipoint injection system. The design is quite typical, so you can see almost identical structure on Volkswagen, Skoda cars. The main difference will be in the way of calculating the amount of air. The diagram shows the design using an absolute pressure sensor, DAD, and a temperature sensor, DTV. Also in MPI engines, the amount of air entering the cylinders can be calculated by a mass airflow sensor, MAF, and a Kármán-type sensor. The main components of the electronically controlled MPI gasoline distributive injection system are fuel supply system, ignition system, air calculation system, exhaust gas toxicity control system. Fundamentals of the operating principle requirements that the fuel-air mixture of a gasoline engine must meet, be in a gaseous state. In other words, for efficient combustion, the gasoline must be completely vaporized before the TPMS ignites. To be homogeneous. The gaseous state promotes good mixing of the fuel with the oxidizer, oxygen, which is in the air. If mixing is uneven in areas with a lot of oxidizer, the risk of detonation increases. In areas with significant over-enrichment, gasoline will not burn completely, resulting in lower engine efficiency. The amount of fuel supplied must match the mass of air entering the cylinders. For the most complete combustion of TPVS, it is necessary to mix 1 kg of gasoline with 14.7 kg of air. Increasing or decreasing the share of air, we get economic, depleted, or power-enriched composition of the fuel mixture. But the range of changing the proportions in the composition is quite narrow, which partly explains the relatively low efficiency of a gasoline engine with MPI injection system, for example, compared to diesel cycle engines. Power system throttle valve, DMRV, DAD, DTV, electronic gas pedal, water cooling, detonation sensor, catalytic converter, DPKV, all. These elements are represented not only in MPI engines. The main feature of the design of multipoint injection on the valves is the fuel delivery system. Reading information about the engine speed, coolant temperature, desired and actual load, vehicle speed, allows the ECU, engine ECU, to accurately calculate the injection time and the amount of gasoline supplied. As a result, MPI engines deliver acceptable torque and peak power with moderate fuel consumption. Advantages compared to carburetor, mono-injector carburetor and mono-injector injection systems have passed into history for the reason that their operating principle did not allow to accurately dose the amount of fuel supplied in all engine operating modes and minimize losses in the warm-up mode. Due to the fact that gasoline was injected directly into the intake manifold, after a cold start most of the fuel portion was deposited on the cold walls of the manifold. Therefore, the mixture had to be extremely rich, which increased the consumption and harmfulness of the exhaust gases. Advantages of engines with MPI injection: precise fuel-to-air ratio. Gasoline is injected by nozzles into the intake valves of each cylinder, so uneven filling is eliminated. The injection torque is determined by the control pulse applied to the injectors. The amount of fuel supplied depends on how long the injector has been open. The MPI engine power system is controlled by the ECU, which calculates the injection torque and the amount of gasoline based on the readings of the sensor equipment. Reduction of gasoline evaporation losses. The injectors are located in close proximity to the intake valves, so there is no need for significant over-enrichment when the engine warms up. The location of injectors close to the valves allows gasoline to remain in the liquid phase longer after injection, which reduces the temperature in the combustion chamber. Any increase in detonation resistance allows the compression ratio to be changed and engine power to be increased. Higher injection pressure allows the fuel to be broken down at the injection stage into finer particles, thus improving its ability to vaporize and mix with the oxidizer. Disadvantages. The disadvantage of MPI engines is that it is an improved, but still inlet manifold injection. If you are familiar with the principle of operation of TSI, TFSI engines, then you know what advantages direct fuel injection provides. It is also recommended to familiarize yourself with the device and comparison of the principle of operation of the main types of engine feeding systems. Features of Volkswagen, Skoda motorcycles. You can find a lot of unflattering reviews about 1.6L MPI engines that were installed on many VAG Group models, Skoda Yeti, Octavia, Volkswagen Polo sedan. Most likely, most of them will be about CFNA models, which at relatively low mileage begin to knock on cold and consume oil. But this is not due to the distributive injection on the MPI valves, but to the design features of the cylinder piston group. In conclusion, the design of an MPI engine is a complex yet fascinating endeavor that combines advanced engineering principles with cutting-edge technology. By focusing on efficiency, performance, and reliability, engineers can create engines that not only meet the demands of modern applications, but also push the boundaries of what is possible. As we continue to innovate and refine these designs, the future of MPI engines holds great promise for enhancing performance and sustainability in various industries. Thank you for joining us in exploring this critical aspect of engine technology.